Welcome to another edition of Math for No Reason. In this edition, we are looking at this problem. Let W be the set of all functions a sin x plus b cos x, where a and b are real numbers. It is easy to check that W is a vector space over the reals. We have to find a basis for this vector space. Now, what is meant by a basis? Two properties needs to be satisfied for a basis. One is that the set must be a linearly independent set, and second is that it must span the whole set. That means the set that we will propose as the basis for the vector space W must be a linearly independent set of vectors, and every element of W we should be able to write it as a linear combination of the elements of this set. Now, in this particular case, it is easy to find the basis by inspection. In fact, I would suggest that the basis B is consisting of these functions sin x and cos x. So, these two functions sin x and cos x forms the basis of W. That is my claim. So, we have to prove this claim. Now, observe that if we have to show that this is a linearly independent set, then we have to show that alpha times sin x plus beta times cos x is identically 0. So, this is the 0 function, not the number 0 but 0 function, if and only if alpha equal to beta equal to 0. This 0 is the 0 of real numbers. So, there are two zeros that are involved. This is the 0 function, which is always 0, and this is the real number 0. Suppose alpha sin x plus beta cos x equal to 0, and here 0 is the 0 function. So, alpha sin x is equal to minus beta cos x. Now, suppose alpha is not equal to 0, then we will have tan x is equal to a constant minus beta by alpha. But tan x is a non-constant function. So, we arrive at a contradiction here. And contradiction to what? Contradiction to alpha not equal to 0. So, alpha is 0. Now, if alpha is 0, then we have beta cos x is equal to 0. Now, if beta is not equal to 0, then we get cos x is equal to 0 for all x, because 0 is the 0 function here, which is a contradiction. So, therefore, beta is also equal to 0. So, what we have shown is that if alpha sin x plus beta cos x is equal to the 0 function, then alpha and beta must both be 0. And that would mean that sin x and cos x are linearly independent vectors, or the set sin x cos x is a linearly independent set. So, the first condition for the basis is met here. Let's see if we can prove that this spans the whole set W. This is relatively easy because every element in W looks like a sin x plus b cos x, where a and b are some real numbers. So, this is a linear combination of sin x and cos x with coefficients coming from the field R. So, therefore, sin x cos x spans W. Thus, we have a linearly independent set which spans W, namely the sets sin x cos x, and hence sin x cos x is a basis for W, as we had claimed. It's a good point to start.